Okay, so here we're looking at combinations, so denoted NCR, and these work in a similar way to our permutations from before, they're just slightly different. So combinations calculate the number of ways of choosing R objects from a pool of N objects where the order does not matter. Okay, so the difference between this one and the previous one is that when we're working these things out, the order in which they are chosen doesn't matter. Whereas in the first one, whenever we looked at permutations, the order we picked the things out did. So here, our NCR is equal to n factorial all over r factorial n minus r factorial. That is our little formula for working it out. So again, because we've made the denominator slightly bigger, okay, hopefully we can see that that's going to reduce the number of possibilities, reduce the number we get out as the answer there. So looking at an example, how many ways are there to select two prefects from 6 pupils? What we've done here is we've chosen the same numbers as we had before. So last time we were looking at a word in first and second place, so we want to get the first 2 people out of a race of 6. And here we want to pick 2 people out of our 6. Remembering, order is not important. So here order is not important. Okay, when we're answering these questions, one of the first things you will have to decide is whether or not the order matters or not. Okay, it is very unlikely that you'll be told this is a combinations or permutations question. You'll need to decide yourself. So, first thing we're doing is we're going to put the numbers in. So I've got 6, that's my total, and I'm choosing 2. So matching that up, I've got 6 factorial over 2 factorial, 6 minus 2 factorial. And so looking at what that is going to multiply out to give me, it's 6 times 5 times 4 times 3 times 2 times 1 all over 2 factorial, 2 times 1, 6 minus 2 is 4, so 4 factorial, 4 times 3 times 2 times 1. So that and that can cancel. 6 times 5 is 30 on the top, divided by 2, leaves me 15 ways in which that can happen. Okay, so worth noting at this point when we're looking at these, that some of these things can give us the same out. So if we've got 6, choose 2, and we are going to go 6, choose 4, that will give the same amount. Okay, that gives us the same answer. And if we think about what it is we're doing, if we're choosing 2 people out of my group of 6, as a result of that, we are leaving the other 4. So in picking out groups of 2, we are also kind of accidentally picking out groups of 4 at the same time. Okay, so we can find that that is what we're going to do. And if we think about what that looks like in terms of our formula, we've got 6 choose 2, 6 factorial over 2 factorial, 4 factorial, and 6 choose 4 is 6 factorial over 4 factorial, 2 factorial. And so the numbers there turn out to give us the same thing. Okay, we find that in general, n choose r is equal to n choose n minus r. Okay, we can make a little bit of symmetry out of this. Thinking about what our formulas are there, we've got n factorial over r factorial, n minus r factorial. And for this one, we've got n factorial over n minus r factorial, lots of n minus r factorial. Okay, and that tidies up for me n factorial over n minus r factorial, and so we can see we end up getting the same thing. We just swap our terms in the denominator about, so we get the same 2 factorials, right? Just the order in which they come in is slightly different. Okay, we might ask you to solve it in a slightly different way. So we might ask you something like n choose 2 equals 6. So what I want to know here is how big does my pool have to be that when I'm choosing 2 things out of it, there are 6 options. So I'm thinking about my NC2 here, my n choose 2, and what that actually means. So I've got n factorial over n minus 2 factorial, 2 factorial equals 6. And my goal here is to try and simplify my fraction down a bit. So from before, looking back to our factorial stuff, remembering that the thing on the top, my n factorial, is the same as n times n minus 1 times n minus 2 factorial, and that was all over n minus 2 factorial, 2 factorial. So my n minus 2 factorials can cancel out. All of that is still equal to 6. 2 factorial is just 2, so when I take that over, I'm going to have n lots of n minus 1 equals 12. Bring it together onto one side, multiply it out, gives me n squared minus n minus 12 equals 0. Factorise it, we get n minus 4, n plus 3 equals 0. And so that gives me my 2 options for n to be equal to 4 or n to be equal to minus 3. And so my answer here coming out to be n equals 4. It can't be n equals minus 3, because n equals minus 3 isn't a suitable answer. Okay, we couldn't have a pool of minus 3 things to have chosen for. So n is equal to n equals 4, sorry. That's n equals minus 3. Is not a suitable answer. And finally, just as a last wee point, the way in which we can notate things, NCR can also be written almost like a wee vector. We've got N, R as such. Okay, so that here is worth bearing in mind as well. You'll be expected to convert between those forms, you'll be expected to see them, and more importantly, you'll be expected to draw a box and join it up successfully.